This is video number 9 on the topic motion in a straight line. Timestamps are given in the description box. You can watch parts of video if you're running short of time. In this video, I will discuss equations for uniformly accelerated motion. That is, acceleration is not changing with space and also time. The first equation of motion is the velocity v is the initial velocity v0 plus at, where a is the acceleration. Displacement x is the initial velocity into time plus half at square. This is motion along the x-axis. And then velocity square equal to the initial velocity square v0 square plus 2ax, where x is the displacement along the x-axis. This is a case where the acceleration is uniform and constant, that is, does not depend on space or time. That means acceleration is a real number. So for 1D motion, let us assume that the motion is along the x-axis. The acceleration is related to the velocity as a equal to dv by dt. That is, acceleration is rate of change of velocity. Acceleration is rate of change of velocity. And for this motion, a is a number because it's uniform and constant. So from this I can write a into dt equal to dv. So integrating both the sides from the initial time t equal to 0 to some arbitrary time t, and the velocity at the initial time, let it be u, and the velocity at the time be v. So this will give me a is a constant, can come out at, and you have to put the limits 0 to t, and this is v between the limits u and v. So this will give at equal to v minus u, that is, velocity at any time v is the initial velocity plus acceleration into time. So this is first equation of motion. And velocity is nothing but rate of change of displacement, that is dx by dt. So that means u dt, you can take this dt here, as at dt equal to dx. Now integrate both sides. This will become term by term integration. Say from initial time t equal to 0 to some arbitrary time, and when initial time t equal to 0, let the displacement be x0, and let the displacement be x at any arbitrary time. So this will give ut, u is initial velocity will come out, it's a constant. So this will give me, if you put the limits, just ut, and this will give me a t square by 2. So it's half a t square between the limit 0 and t. So if you put the upper limit, get t square, lower limit will just be 0. And this will be x minus x0. So this is second equation of motion. First equation of motion gives velocity as a function of time. Second equation is displacement as a function of time. You can also get another form of this relation. Here I can take t common outside. So u plus half at into t, and then 2u plus at by 2 into t, and one u I'll keep like this as u, and the second u plus at I can write as v by 2 into t. So displacement also given as average velocity, that's u plus v by 2 into time. And this one can also be, this thing is displacement in terms of initial velocity and time. So here also I can get in terms of final velocity. Instead of ut, I can get in terms of v. Here itself I can write u as v minus at by 2. U is nothing but v minus at plus v by 2. I am eliminating u, so this will give me v minus half a t square equal to the displacement x minus x naught. So this I can call third equation of motion, and this is fourth. Here there is a t here, so it will be vt. So displacement is ut plus half at square, and also vt minus half at square. And one more equation is squaring this one on both the sides. I get b square equal to this square, that is u square plus a square t square plus 2 u a t. So here if I take at common outside, that will give me at plus 2u I have to eliminate t. V square equal to this one. So from here I have, let me call this as displacement, yes, for convenience. So from here I have u plus v equal to 2s by t, and from here I have v minus u equal to at. So if I multiply these two, I'll get v square minus u square equal to t will cancel, so 2as. This is the fifth equation of motion. So acceleration is related to velocity as c equal to dv by dt, and v is again dx by dt, so it will become d square x by dt square. So this, if I integrate both sides, I'll get at equal to v minus u. Time is changing from t equal to 0 to t, and velocity is changing from u to v. So from this I get v equal to u plus at, which is dx by dt. Again I can integrate one more time with respect to time. That will give me x equal to ut plus half at square. Here x is 0 at time t equal to 0, that is x naught is 0. So this I can write as t plus u plus half at. If I take t outside, and then take half outside and become u plus u plus at. So this will become average velocity to time is the displacement x. And then is equal to ut plus half at square. So instead of u, I can write as v minus at. So that will give me vt minus half at square. So this is either ut plus half at square or vt minus half at square. Velocity is at any instant of time is between u and v, because initial velocity is u and the maximum velocity, because we assume a is positive. If a is positive, v will increase. So velocity at any time will be between u and v, and the displacement is greater than ut by half at square and less than vt by minus half at square. So displacement between ut and vt. V square is u plus at whole square, u square is 2at plus this one. So if you take 2a, I'll get ut plus half at square, so that's displacement x. So v square equal to u square plus 2ax. So here velocity is a function of displacement. For a given acceleration, initial velocity at any displacement is given by this relation v equal to u square plus 2ax. Velocity at any time is given by this relation v equal to u plus at. So as velocity is a function of time, this is also a function of displacement. That relation is v equal to square equal to u square plus 2ax. And distance traveled in n second, the meaning is distance traveled in n second is the distance traveled in n second minus the distance traveled in n minus 1 second. Because let's say at time t equals 0, the thing is here, it's moving like this. So t equal to 1, it will be here. T equal to n, it will be here. And then here it will be at t equal to n minus 1. So the first second is between 0 and 1. So nth second will be between n minus 1 and n. So distance traveled in n seconds, which is from here to here, and distance traveled in n minus 1 is from here to here. So this is dn. This distance is the distance traveled in n second, which is distance traveled in n seconds minus the distance traveled in n minus 1 second. So here I can use distance traveled in n second as ut plus half at square, u is n plus t plus half, e is constant, and t square is n square, minus the second term n minus 1 ut is u into n, and second ut is u into n minus 1 plus half a times square is n minus 1 square. So u and l can cancel, so we'll get just u, and then plus half a n square minus n minus 1 square. So here there will be n square, that will cancel because of this minus sign, and then minus 2n will get plus 2n, and then plus 1 will become minus 1. So this is n second is of the form ut plus half at square. Ut is the time interval of 1 second, so just u into 1, and then half a t square is n square minus n minus 1 square, that is 2n minus 1. So this is also a formula which can be remembered. So here the first one, the displacement is changing as a function of time. So if you see the equation of motion, x minus x naught equal to ut plus half a t square. Let us assume, okay, x naught, let me put it here. X minus x naught is the displacement. So time t equal to 0, displacement is x naught. So this is a parabola with respect to time. Time is on the x-axis. So this parabola can be either, if a is positive, the parabola will be like u, positive, if a is positive. If a is negative, it will be like inverted u. This is property of parabola. Okay, so here in this case, a is positive, so it's like a parabolic u shape, and negative a, so this t square term is negative, so it's inverted parabola or inverted u. And here in this case, at time t equal to 0, so this is x naught. And initial velocity is the slope of this curve dx by dt. So it's a negative slope, so u is negative. Here in this case, this is x naught, and the slope, the initial slope, it's positive. And at a later time, the final point here, velocity is negative, velocity is positive, here is negative. So for the first case, the trajectory will look like this. Trajectory is the path of the body. It's positive v. So this is x naught. So initial velocity u is negative, so it will go like this to start with, and then a is positive. Acceleration is towards this direction. So this velocity will keep on decreasing. At some stage it becomes 0 and then return back. So at this turning point, the velocity is 0. There is this point. Suppose this time is t1. So this is the time instant t1. After that, after this point, the velocity is positive and the keep on increasing. Here velocity is say v greater than 0. From here to here, v is less than 0. After that, v is 0 here, and then v is positive. So initially negative velocity 0 and then positive velocity. Negative velocity, negative, negative, 0, and then positive velocity. So this is this motion. Similar second case, this is the trajectory. Start from x equal to x naught. This is the x-axis, and u is positive, so it will start moving towards right. And acceleration is negative, so acceleration in this direction. Acceleration is negative means force is also negative. Force and acceleration are just different by a factor in the mass. So force is in this direction, acceleration in this direction, there is some force in this direction. So the velocity will keep on decreasing. So after some time, it will become 0 at this turning point, and it will become negative. So initial velocity is positive from here to here, 0, and from here the velocity is negative. So the thing will go on like this. So initial velocity is positive, here it is 0, after the velocity is negative. Third case, and velocity at any time, which is the slope of the curve, it's constant because it's a straight line. So the acceleration is 0. When acceleration is 0, that means dv by dt is 0. That means velocity is constant, not a function of time. So for this, the trajectory will look like this. Let this be x naught here. Let this point be x naught. Initial velocity is positive, so we'll move towards right. I'll keep going on. Acceleration is 0, so there's no force. So what is the velocity? We'll move the same velocity. Suppose the velocity here is 2 meters per second. It's always 2 meters per second. I'll keep moving on towards right. So these are 3 examples, motions. Let me solve this problem. The position of an object moving along x-axis is given by x equal to a plus bt square, where a is 8.5 meter, b is 2.5 meter per second square, and t is measured in seconds. What is the velocity at t equal to 0 and t equal to 2 seconds? What is the average velocity between time t equal to 2 and t equal to 4 seconds? This is a simple and straightforward question. It's a 1D motion along the x-axis, and x as a function of time is given. The velocity is, by definition, rate of change of displacement, which is x here. So that will give me v into 2t. So velocity at t equal to 0 is 0, and velocity at 2 seconds is 4 into b, and the b value is 2.5, so it's 5 SI units meter per second. Average velocity is defined as the displacement delta x over the time delta t. So here you have to find the displacement between the time interval x equal to 4 seconds and at x equal to 2 seconds, minus the time interval is 2 seconds. 4 minus 2 is 2. So x at 4 seconds is A and A will cancel. X at 4 seconds is 16b. At 2 seconds will be 4b divided by 16 minus 4 is 12, so it is 6b, and b is 5 by 2. So it will be t into 5, so 15 meter per second. That's the average velocity in the time interval 2 seconds to 4 seconds. Four b, velocity at the end of 2 seconds is 4b, and b is 5 by 2. So 1 2 will cancel, so it's 10 meter per second. B is 5 by 2, so 1 2 will go. So velocity is dx by dt, and x is given as a plus bt square. So that will give 2 pt, so 5t meter per second. At t equal to 0, it's 0, and t equal to 2, it is 10 meter per second. Average velocity is displacement the time interval, that's 2 seconds to 4 seconds, which is x4 minus x2. Remember the time interval is 2 seconds. So from this, you will get 15 meter per second. You can ask your doubts in the comment section.